welcome to today's video on describing and performing reflections. So we're again in the unit of transformations, which are changes in the position, shape, or size of a figure. And then we're also focusing in now on rigid transformations, transformations that keep the size and the shape of the figure the same. So we're just moving the position. And another way of saying this is transformations where the preimage and the image are congruent. Okay, so congruent means shapes with the same angles and the same sides. It's like it's similar to the word equal, and it's really saying they're the same. They're the exact same thing. They've just been moved. The position has changed. So we've already looked at translations, which is when we slide a shape. But today we're going to be looking at reflections, which we've already heard and thought about as like a mirror or a flip. Those are less technical words to think about a reflection. But today we're going to dive into the details. Okay. So the technical math definition of a transformation, of a reflection, is a transformation where the preimage and the image points, so all the points in the original figure, the preimage, and the image, the shape after the reflection, are the same distance away from the line of reflection but on opposite sides. Okay, so if we look over here at this example, we see we have ABC and A prime, B prime, C prime. To get from B to our line of reflection, in this case, which is the y-axis, we are 2 away. B is 2 away from the line of reflection. And then if we see from B prime to the line of reflection, we are also 2 away. So the points on the preimage and the image, those that correspond, B and B prime in this case, they're the same distance away from the line of reflection. They're 2 units away, but on opposite sides. So that's how we define it, and you'd see the same with A and A prime and C prime as well. Okay, you can see this in this picture with the green. You see they're showing us that the distances from each of the 3 points to our line of reflection is the same, but again, those are on opposite sides of the line of reflection. So we'll mainly be looking at lines of reflections that are either vertical lines up and down or horizontal lines left and right. But as we see in this last picture, you can have a line of reflection that's diagonal, absolutely. And in those cases, just as a note, and in the vertical and horizontal cases, we're thinking about the distance away from the line being the distance that takes any point and then forms a 90-degree angle or is perpendicular to the line of reflection. That's the way we think about distance, and like opposite sides is based on that perpendicular idea. Okay? All right, and then 2 key concepts that we already saw in class is that when you reflect across the x-axis, the x-coordinates are going to stay the same, and then the y-coordinates will switch signs. So one way of writing that is like we have the points x comma y, and when you reflect across the x, you're going to have x comma negative y, meaning we're switching the signs of the y value. And then when you reflect across the y-axis, the opposite is true. The x-coordinate switches sign, and the y-coordinate stays the same. All right, so let's perform a reflection. So this question asks us to graph the image of triangle ABC across the line x equals 1. And we're asked, what are the coordinates of the image? Okay, so the first thing we have to figure out here is what is the line x equals 1? So this might be a new concept to us. Okay, so the line x equals 1 is going to be the line that's formed from all the points where the x value is 1. Okay, so let's think about what that means. So this is my x-axis, this is the y-axis, and then here, this is my x equals 1 situation. So like this point right here, this is the point 1, 1. This is the point 1, 2. This is the point 1, 3. This is the point 1, negative 2.5. All of those points have an x value of 1, okay? And that's going to be true for any point along this line that all of those points exist on. Okay, so we call this point, this line, x equals 1. It can feel somewhat counterintuitive because it's parallel to the y-axis, so we might be inclined to think of it as like y equals 1. But think again about the fact that every single point on that line has an x-coordinate of 1, and that's where it comes from. Okay? All right, so we're going to make that our line of reflection, x equals 1. So how do we reflect triangle ABC across this line? Well, we go back to our definition of a reflection. A reflection means the points on the pre-image and the image are the same distance away from our line of reflection, but on the opposite side. Okay, so our goal is going to be looking at our three vertices and see how far away are those points from the line of reflection. And then move them that same amount on the opposite side. So we'll start with B. Okay, so this is B right here. B is only 1 unit away from the line of reflection. When we again get this 90-degree angle, we go directly right. Okay, so that means to find B prime, the reflected B, I'm going to go 1 unit to the right of my line of reflection, and that's going to be B prime. Okay, all right, then let's do the same thing for A. So I'm going to go directly, make that 90-degree angle, straight right, and try to get from point A to my line of reflection. So that's 1, 2, 3, 4, 5. 5 units from A to the line of reflection. That's on the left-hand side. So we just need to go 5 units right from the line of reflection to get at A prime. 1, 2, 3, 4, and 5. So this now is going to be A prime. Again, this works because I have the same distance from my line of reflection, but on opposite sides. And then finally, I can do that with C. C is going to be a distance of 7, if we count those squares. So we're going to go 1, 2, 3, 4, 5, 6, 7. It's a distance of 7, so this is going to be C prime. All right, so far I now have my points all set up. I'm going to erase these distances because that's going to make it hard to see what's going on. And now I have 3 new points, A prime, B prime, and C prime. So to get my new triangle, A prime, B prime, C prime, I just need to connect the points. And now you can see, of course, it would be a little bit nicer if I had a ruler and I drew it perfectly. But you can see I now have the exact same image, right? ABC and A prime, B prime, C prime are congruent. They're the same angles, same side lengths. They're like the same shape, just flipped across, repositioned and flipped across our line of reflection. All right. So that's everything except for the fact that this question asks us both to graph it and to tell us the coordinates of the image. So we're going to have to say, what is A prime, what is B prime, and what is C prime? I look at A prime. A prime has a x value of 6 and a y value of -3. So that's going to be the point 6, -3. B has an x value of 2 and a y value of 0. It's not going up at all. So that's the point 2, 0. And lastly, C has an x value of 8 and a y value of +2. So this is going to be the point 8, 2. All right, and that's how we did it. We found the distance our original points on the pre-image are from the line of reflection, and then we go that same distance on the opposite side of the line of reflection in order to get our image, our new points, and our new triangle. Lastly, let's look at this example, which is asking us to describe reflections. So it says, describe the reflection rule that takes triangle EIQZ to its image E prime, I prime, Q prime, C prime. All right, so I see that this has been reflected. I have my original shape in black and my new shape in red. Now, you might be able to just kind of like mentally imagine this line of reflection. Like, where is this seeming to be mirrored over, reflected over? And that's fantastic if you can do that. If you can't do that or you're not sure how that works, I'm going to go step by step for how we can see this. So I'm going to pick my 2 points that correspond, any 2 points that correspond from the pre-image to the image. So here I have Q prime, and then this is Q. Okay, I know the definition of a reflection is that those 2 points should be the same distance from my line of reflection, but on the opposite sides. If I connect those 2 points and then cut it in half, I'm going to find my line of reflection. Okay, so if I cut that in half, then it's going to put me right here. Now, why did I cut it in half? Well, I have the entire distance from Q to Q prime. I know that that distance needs to be cut in half because the distance on one side to the line of reflection and the other side has to be the same. Okay, let me try to do the same thing with z. So here I have z prime and z. I'm going to draw a straight line. Currently that is 1, 2, 3, 4, 5, 6 units. So I'm going to cut that in half by going 3 units up or down, depending on which I start at. Okay, when I did that, now this top from z prime to that, what will be our line of reflection, is 3 units. From our line of reflection to z is also 3 units. So we have two distances that are the same, but they're on opposite sides of our line of reflection. And then we could see something similar with our last points, I and I prime, although that's actually given us kind of a good indication of where our line of reflection is as well, because I and I prime are the same point. Okay, so that means their distance from the line of reflection is 0. So they're on top of each other. Thus, the line of reflection has to go through that point as well. Okay, so we've done that with all 3 points. Thus, we're going to figure out that our line of reflection is this line that connects all of them. Now, again, that might be something you could kind of see in your head and imagine the reflection. If so, fantastic. You can do that, but just check to make sure that the distances from the points on each side that correspond are the same distance from your line of reflection. All right, so lastly, now we've drawn it, but this is saying describe the reflection rule. So our job now, we drew the line. We need to figure out, what do we call that, right? What is the equation that would draw that line? Okay, so if I think about all the points on this line, and pick that point. That's the point 3 on the x, and then -2 on the y. Okay, let's pick another point. This point over here, that's 1, 2, 3, 4, -4 on the x, -2 on the y. This point right here, it's 0 on the x and -2 on the y. So the y coordinate for every single point along this line is -2. Okay, so that's why we call this line y equals -2. On this line is every single point that has a y coordinate of -2. And then we have all the different x coordinates. Okay, so we would say that EIQZ is reflected across the line y equals 2. Y equals -2. And that's going to describe that reflection rule. Okay, that's all it is. So we're just making sure the key idea of reflections, in addition to kind of our informal language of flip or mirror, is the formal definition that our points on the pre-image and the image are the same distances away from the line of reflection, but on opposite sides. Okay, great job, everyone.